So we have the climate models, but then we also have what are the predicted changes in emissions due to human activity. And for that, the IPCC has created a set of scenarios that they group into about 6 different families, ranging from high emissions to low emissions. And these are actually put together by economists working with scientists. And we chose the highest emissions one and the lowest emissions. So we were able to look at both of the predicted extremes. The highest emissions trajectory, which is called the A1F1, assumes very rapid future global economic growth, new technologies, increasing global convergence and reduction in regional differences in per capita income. That results in the highest predicted emissions. The lowest trajectory includes global economy that emphasizes services and information, reductions in material intensity, introduction of resource-efficient technologies. So these are separate models, not run by us, but run by these teams of economists that make predictions about consumption and GDP based on those scenarios and then the consequent emissions. So now we needed a way to simulate future weather based on these economic scenarios and global climate models. And we used a weather generator, and I'll explain how that worked. This is something called the WGEN, Stochastic Weather Generator. It uses Markov chain gamma distribution model. What it first does is it looks at historical data. And as Kamilya had mentioned, we have actual daily weather data for an area very close to our villages in northeast Thailand. And this is a plot of all that data. The red is daily precipitation variation. Over here we have 1972, and up here 2003. The blue is maximum daily temperature, the green is minimum, and the purple, I don't know if you can see it, is variation in solar radiation per day. And we're able to use this weather generator to generate stochastic simulations. So the way the model works is it first takes 30 years of historical data, and it creates a large table of summary statistics describing both the monthly mean amounts and also intercorrelations between variables, the probability of dry days, the probability of wet days, and then it uses that to generate stochastic weather. So using all of that, so this is kind of a summary of the process. We start with the historical data. We generate a large table of summary statistics. We then ran 3 different scenarios. The first is what we call neutral, where we have no climate change. We just take the historical parameters and assume that they extend, so there's no forced climate change signal. And then we modified the table according to predictions from the SRES scenario for the ensemble mean AOGCM models, modified those for predicted offsets for Southeast Asia for the 2040 to 2069 time period, and then generate stochastic realizations off of that. And we did the same for the low emissions. So the difference is that with these climate change modifications, we're getting predictions of likely future weather conditioned on the existing trends and patterns in the historical data, but modified slightly for the climate change signal. And using that, we then go back to DSET and we simulate yields. And we had 100 realizations for each scenario, so we produced 100 realizations for each plot, for each of these. So 300 total yield runs per plot. And the weather generator does a random draw to generate these different stochastic realizations. So we get a distribution for each plot. And that then goes back into Kamilya's economic model. Yes?
Yeah, so what you want to do in the end is predict yields for some time period in the future, right?
Right.
So what I don't understand is, so you're saying that the economic scenario is going to affect the evolution of weather and global climate change.
Yeah.
Wouldn't you think that it would also go the other way, that the evolution of the weather is going to impact the actions that people take? So, for example, they're just going to change the crops they plant. They're not going to plant rice anymore, for example. Maybe a bit like there's like a huge.
That's true. I mean, we haven't incorporated a huge amount of possible farmer changes to these different climate. But what we're able to do is to assess what are the sort of mean baseline changes in expected yields, and we haven't modeled change in planting date or other farmer adjustments that they're likely to make. But the general consensus is this is. Kamilya will now talk about the results. Actually, maybe she can get into that a bit more.
Going up on what he's saying, like the high emissions is based on an economic model itself, right?
Right.
Which is like high economic growth and stuff. So that should be changing the like wealth and stuff and things like that inside of people.
Yeah, I mean, it's a very complicated system here. Predicting future climate change is very complicated because it's a global system, endogenous interactions between the weather and the economy. And this is sort of the best guess that science can make. What are the likely changes in emission due to these? So we don't know exactly how the farmer economy is going to interact with the global economy changes. But by doing this, we can really isolate what is the signal change and what is the baseline change in yields.
John, did you do variance decomposition on this?
Did I do what?
Variance decomposition into different factors?
We did to a certain degree, and I think I'm going to turn it over to Kamilya because she could maybe talk about that a little. She's going to discuss the results of this.
So, if you have questions on climate change scenarios, you should ask John now, because I'll talk about the model and then the results.
So can you talk about that about 0.6? I guess it's your
Yeah,
okay.
but I'm just in case people have questions about climate or weather simulation.
But you didn't actually did you actually run the climate model, or you just
No.
took some results
We
under
took
those scenarios, right?
the IPCC ran more than 20 climate models together under a supervised administration so that the outputs and inputs were standardized, combined those and took the mean result. And they did it for 10 different sub-regions of Asia. So we took the predictions for Southeast Asia.
And then
And is
you
that
ran
just
them-
the temperature prediction, or is it a temperature
Offset.
precipitation?
Monthly offset changes to temperature and to precipitation. Those are the primary.
And we able to propagate the error from those projections through these stochastic weather simulations? Like, is that taking over?
Well, the theoretically, this is the predictions that minimize error just about more than any other model, because by running ensemble mean, you reduce the bias inherent in any particular model, and no one knows exactly what's going to happen to the economy, but the SRES scenarios are sort of the best guess of a large group of economists. So we're basically taking that output. We figure that they could do a far better job than we could have. We're not climate modelers, but we can take their predicted output. And this is all reported. Last year, the IPCC came out with what it called its fourth assessment report. It's all on the web. And these predictions were in that fourth assessment report. So they were intended to be used by scientists for this type of modeling. And it's about the best guess that anyone in the world has of what are going to be the likely
But that report
changes.
produces temperatures with error bars on it.
Yeah,
right?
it does. Yeah, you can
But
look
you just
at
use the mean values.
We
of
just
those.
used, the mean values, right?
Is the variance of temperature also changing? So like you're talking about the mean increasing by 2 degrees or something, but is the variance of temperatures over time going to change?